Hi, this is Joe. It's my pleasure to introduce you to the FYP I've been working on so far. The title of my FYP is called Smart Projector Embedded with Visible Light Communication VLC. As a motivation, we know that the large buildings such as the shopping center, the airport, the museums, and universities are being constructed in large cities in recent years. So as a result, people like you and me are spending more time indoors every day, and that increased the demand for communication between the people and those large buildings. So there is a widespread of the use of indoor services. But what is the indoor services? For example, when you are visiting a museum, you want to know more about one item that is close to you, then you put your phone close to that item, and suddenly the introduction of that item will appear on your phone. That is an example of a smart indoor service. However, there are some problems. The communication technology like Wi-Fi or Bluetooth have some drawbacks, like the low data rate, the high cost, or low efficiency. And those problems will cause a trouble when we are implementing some advanced indoor services. And that is the motivation why we are using VLC in our project. So our project is aiming to fill the gap between the supply and demand for a technical support for those indoor services. In order to do that, I present such a system that includes a smart projector embedded with VLC. There are basically two parts in my system. The first part is a transmitter, which is basically a projector like here. And the second part is a receiver that is a mobile, and that is an app on a mobile phone to do the visible light positioning to find the camera location of the user. So let's take a look at this photo. The user is using a headset to receive the light from the wall, and the headset must know where the user is, and that is what the VLP is doing. Okay, let's move on to see the structure of my project. There are two parts as mentioned before. The red parts represent the transmitter and blue parts represent the receiver app. There are several technologies used in these two parts, and I'm gonna introduce you in the next steps. Okay, so far I have been working on the receiver part, which is the app to do the VLP in order to find the location of the camera. The basic workflow is shown here. First, you can give me a photo, whatever, like shown here. Then I can tell you where the corner and the edge is. And then, based on that, I can find the angle of the camera when you're taking the photo. Based on this calculation, I can further estimate the location of the camera. And this is basically what VLP is doing. There are several things that have been used here, like the Harris corner detection, the Hoff line detection, or the canny operator. They are used here to assist the performance of VLP. Of course, there are some challenges, technical challenges, like the camera lens distortion that will affect the result of the angle calculation, and the error in the angle calculation will also influence the outcome of the camera position. But those errors are quite small that we can ignore them. In this part, I attached some photos to demonstrate what I've done in the previous part. And the first step is called the corner detection. You see, there are two input photos, and I can tell you, I can find the shape of this object and show them in green color. It's done automatically. And the second part, I apply the visible light positioning to a very simple image like shown here. So based on this image, my algorithm can tell you where your camera is, which is the location. And in the third step, I'm going to use the same algorithm to find the location of the camera based on a more complex photo like here. This is like a barcode, and this is what a VLC will represent you here. So as a conclusion, the testing result shows that my algorithm works quite well and the data rate is quite low. And that means the software part of my FYP is basically done. And in the next step, I'm gonna work on the hardware part, which includes the design, implementation, and testing, and they will be done in 1 or 2 months. So I will present you with an intact smart projector with embedded VLC, and hopefully that will work very well. Thank you.